gracia le vivir.
We're gonna go in depth on these two topics today. Okay, so let's move on to the first one, limits. All right, what does it mean by limits? Okay, so let's say we have a function of x, f of x. So the function f of x is said to have a limit a. This is a number, okay, or so I just put a there. As x approaches little a, so in math form, I will write it like this. Okay, so the way to read it is like this. Okay, so as x approaches a, okay, little a, as x approaches little a along the x-axis, okay, and then so this is how to read that. This function tends to this limit. Okay. So okay, that this is the expression, mathematical expression. This is how you read it. Okay. And here's what it means like graphically. All right. So for example, let's say you have on the let's say this is a function f of x. Okay, so this is a function f of x, and you want to see like as x here approaches this value here, this number here, a. Okay, from the right and from the left. Okay, and according to this, it should approach a here. So So let me draw a line here, a straight line here. Okay. So what it's saying is that you see, if you if x is approaching little a, either from left hand side or right hand side, okay, you can say the limit is a right here. Okay, you will see some really funky functions later on. Like for example, I showed you before this function where it goes something like this. Okay, it goes something like this. All right, and then I ask you as x approaches infinity, what will be the value of what would fx be? So as you can see, if you go along that function, you can see as x tends to infinity, f of x tends to 0. So it's just going to go closer and closer and closer to x. So this is what it means by limits. The reason we learn this is this. We want to analyze the behavior of a function when it is in the vicinity of a certain point, and like near a certain point. For example, in this case, what happened to the function when it is close to little a, for example? So you can see, well, the function when x tends to, or x approaches little a, you can see that the limit will be big A here. All right. Same thing here. We want to analyze what's happening at infinity. When x keep on growing, what will happen to f of x? So here, using our knowledge here, we're gonna learn now. We see that we can analyze it. We can say that, okay, depending on the function, really, we can say that towards infinity, f of x will be closer and closer to 0. So we'll say that the limit of this function here as x approaches infinity tends to 0. So this question right here, so I have 5 examples here. I want you to type out the answer if you can, or you can use the mic to show. Okay. So example number 1. So this is the function. So this is the function x squared minus 4 times x plus 8. What is happening to this function when x approaches 1? Can you tell me the answer?
Is it 5, Doctor?
Is it 5? Okay, let us see. What we can do right now, it's kind of easy. What we can do is just let's try replace x this by 1, 1, 1 minus 4 times 1 is 4 plus 8. 1 minus 4 is minus 3 plus 8 is 1. Yes, the answer is correct. Okay, so this is an easy one. Now we got this function right here, x squared minus 4 divided by x minus 2. What happened to this function as x approaches 2? Let's do some trick here. So here we require some kind of trick. We know that through some, your algebra witchcraft that you've learned in your high school. Okay. Can you agree with me that you can actually expand this to x plus 2 times x minus 2? Am I correct or am I right?
Yes, definitely.
Yes. Okay. Yep.
Right.
So I'm expanding this top here, the numerator here, into x plus 2 times x minus 2. Now what I can do is I can cancel these two out with two same terms. So right now I'm left with x plus 2. Are you following now? And then now it becomes simpler. The expression becomes a lot simpler. Okay, now I have this only. So now can you give me the answer? It's easy. It's 2 plus 2. The answer is 4. What will happen to this function sine of x divided by x when x approaches 0? Now this is another problem similar like before, because sine x is what? Sine x is 0 and x is also 0. So what we got here, if you want to substitute like up here, what we done here, okay, well, cannot be done. It will be 0 divided by 0. Okay, so what can we do here?
Into cos.
Change it into
Sine t
cos.
into cos 0
Why do
over
I need to change it to cosine?
L'Hopital rules.
Wow. Okay, yes. Okay, L'Hopital's rule, you can use that too. Uh, who was that just now?
Larissa.
Okay. So what she was talking about is, I forgot how to spell his name. L'Hopital. L'Hopital's rule, okay? L'Hopital's rule. Yeah, you can use that. But let me show you one example which I think I want to teach you, okay? You know the law of small angles? Law of a small angle approximation, okay? So you say here, small angle approximation can be used to approximate the values of main trigonometric functions, provided that the angle question is small and is measured in radians, okay? Now, what it's saying here is this. If theta here, or in our case, it's x, okay? Then if theta is really small, then it can be approximated as a theta. All right. Now, because we are checking the limit when x is approaching 0, when x is really, really, really small, when really, really, really small. Okay, so that means x here is going to be, we are looking at the case where x is really, really small. So this one, we can actually rewrite it using small angle approximation because x is approaching 0, meaning that x will be really small. So up here we will have x and down here we'll have x. Why do I change sine x to x? Why? The reason is because small angle approximation. You are going to use a lot of this in engineering afterwards. Okay, same thing like cosine. If theta is really small, then cosine will we can approximate cosine theta as 1. Tangent, similarly, you can if theta is really small, tangent theta can be approximated as theta. Limit of x approaching 0, x divided by x is 1. So what's the limit? It's 1. So let's move
Yes.
on to the next example. Okay, now I'm giving you this function right here, x cubed, x squared. Now the question is asking you, what will happen to this function when x approaches infinity?
Is the limit going to be infinity also?
Ah, yes, good answer. Yes, the limit is going to be infinity also because, well, easily, one way you can do it is, you know what? Let's imagine that this x is here is really big number, really big number. All right, really big number. I just put infinity here, but actually I can't do this. This doesn't make much sense. Infinity squared, so it is infinity. That's one way to do it. Yeah. Okay. But you can also, look at this right here. You can also investigate using your Wolfram Alpha scale. Okay, you plot this function. Okay, and you can see that it's going to keep on increasing when x is increasing. All right, so let's say x is from 0 to, I don't know, 10,000. What's going to happen? Okay, you're going to see that it's going to keep on increasing. So when x is approaching infinity, fx is also going to approach infinity. Let me do a poll here. Let me do a poll here. Tap, tap. Okay, what is the limit of x to, what was it just now? Infinity. Infinity. And the question is sine x. All right. So this is the question. All right. What do you think it is? What's given the function sine of x? What's the limit of function as x approaches infinity? Who is not sure, leave a reaction here. Don't follow the majority. So one way we kind of want to look at this, it's let's try plot sine function. All right. So we plot sine function. Let's do a bit more crazy one. X from, let's say, 0 to something really high. Yeah, 100. Let's try that. Ooh, see, it will go on like that until infinity. Okay, it's not 0, it's not 1, it's not infinity either because it's not blowing up. It's not like going up and up and up. Okay, so we say that the limit here does not exist. Okay, I just reminded. I want to give you another one here. I want to give you another one. Let's say. Oh, sorry. I want to plot x squared times sine of x. X from 0 to 1,000. Oh, eh, hey. Uh, okay, I just want to make it more, make it prettier. Okay, so your function now looks like that. So my function is this. Okay, I will leave this as a homework for you to figure out. Okay. So now I want to go through what we call a one-sided limit. Okay, one-sided limit is when we have. I think I showed you a function just now. I showed you a function where yeah, let's. This is an example. 1 over x. If I plot 1 over x, okay, I have something like this. Okay. Now I've already asked this same question in the WhatsApp before, so I get something like this. All right. And this is obviously 0, and this is y, and this is x. Okay. All right. All right. So now, what I say one-sided limit is this is the reason, yeah? Okay, look at this example here. So this function is actually fx equals to 1 over x. So that's the function. This is the proof that that is a function. Okay, I'm just sketching there just to prove my point. Okay, now I'm asking you here. So what's the limit of this function 1 over x when x is approaching 0 from the right-hand side plus? What's the answer? And then if x is approaching 0 from the left-hand side, minus sign there, okay, what would be the answer? All right. So in the WhatsApp group just now, we've discussed this morning. I think it was it Ame who tried to answer that? Was it you, Ame?
Yes.
Oh, yeah. Okay. Yeah, I think your answer is correct. Now, let's look at this question right here. Here, this one. Limit of 1 over x as x approaches 0 from the right hand side plus. So you can see that as x is approaching 0. All right, so if we approach 0 here from the right hand side, so as you can see, the function goes to infinity. All right, goes to plus infinity. It goes up and up and up. You won't even touch this. It goes up until infinity. So this answer right here is plus infinity. Now, when the well, different thing happens when you approach 0 from the left hand side. Okay, as you approach this, you can see that it's going f of x or y is going to be minus infinity. All right, minus infinity. So now you can see, although both have infinity, but the one approaches plus infinity, the other one approaches minus infinity. So what I'm saying here, what I want to show you here, excuse me, what I want to show you here is the limit of 1 over x as x approaches 0 from the right hand side is not the same as limit of that same function when x approaches 0 from the left hand side. It's not the same. One is plus infinity, the other one minus infinity. So the conclusion we can do here is that the limit, okay, this limit here when x approaches 0 from both sides here does not exist. It doesn't exist. Okay, and why? Because this is the reason. Okay, so let me conclude this. The function is 1 over x. We want to see what happened to that function as x approaches. What's the limit of that function as x approaches 0? Okay, we see that if we approach it from 0 from the right hand side, it's plus infinity, and left hand side is minus infinity. So it's not the same. So because they are not equal, so we can say the limit of 1 over x as x approaches 0 does not exist. So this is a case where it doesn't exist. Let me show you a case, another case, and I want you to decide. Okay, I want to show you a function. I'm just gonna sketch it here. Okay, excuse that. All right, and the function is like this: straight line there, straight line there. Okay, so this is y, this is x. This is the function. I'm gonna name this function maybe I'm gonna use h of x. The function is an absolute value function. Okay, it looks like that. Okay, if you don't believe me, let's plot these functions here. Absolute value x. So it looks like that. It's like it looks like a V where it's you can imagine if you have fx equal x, which is a straight line, but anything if x is less than 0, it's gonna the value of f of x is going to be positive because it's all absolute value. So, okay, this is the function. So let me ask you this question then. All right, limit of this function as x approaches 0. What is the answer?
0.
0. Who's does anyone wants to say does not exist? Okay. The answer is 0. Who was that just now? Siapa tadi? Yang menjawab? Siapa?
Shafi.
Oh, Shafiq. Good job, Shafiq. Now, why do you say it's 0? Why are you confident? One way is observation lah. Okay, you can see if x is approaching 0, then it's going to be in both sides it's going to reach the 0 here. Also, one way you can see that if we approach if x is approaching 0 from the right hand side, this is also 0, and if we x is approaching 0 from the left hand side, this is also 0. So both is the same. So the limit exists, and it is 0. Okay? All right. So that is some examples of limits. There are many ways of investigating the limits, as we know before. One, let's just recap a bit. Okay. One, what we can do is to analyze the function. That means if you're given a function just now, if you're given this function here, something like this, you can analyze it. So I'm analyzing it different way. For the first for the first question here, what I'm doing is just I'm substituting everything with 1 because it's asking me to check what is the behavior of this function as x approaches 1. So I'm substituting everything, easy. So now here I'm analyzing it again. Now I'm doing it differently. I'm expanding the numerator here, and then I found out it can be simplified. So I got the answer for here. And then here I use the small angle approximation because x is approaching 0 here. Okay, if x is approaching any other number like 1 or infinity, you cannot use this. Okay, it won't be correct. So I'm using that one. So this one is also, yes, I'm using analyze. I'm just substituting x with infinity and see what happens. That's the easiest part. And for sine x, what we did is one thing we can do is we analyze the graph. The graph or the plot. Okay, so when you look at the plot and then you realize that, hey, it's not going anywhere, it's just jumping up and down. Okay, so at infinity is still going to be jumping up and down. So here we call this does not exist. Okay. Now we did the same with this one also. Okay, this is what we call one-sided limit. We check one side, and then this here we check one side, and then we check both sides. It's not equal, so we conclude that the limit does not exist. Okay, this is also what we're doing is analyzing by using the graph. Okay. Here, what we did also the same thing. We analyze it using the graphs. Okay. So f of x given f of x is x squared. Now, prove that the limits of that function f of x as x approaching 2 is 4. Now, how do I do that? So you're seeing here if given any number epsilon positive number, we can find a number delta, which is also a positive number, such that now f of x minus the limit of that function at x approaches small a is less than the epsilon whenever 0. Okay. All right. So this is the definition that I've given just now. So how to use this? I'm just going to show you an example of how we can use this definition to solve this problem right here. Okay, we are solving this problem. Okay, but we are using this idea right here. Okay. So what we do, we must show that for any number, positive number, we can find another positive number. Okay, well, this depends on the epsilon in general. All right, such that I would say here, let's rewrite this right here, such that okay, f of x is what? F of x is x2, such that x squared minus, what was the limit? Big A is 4, minus 4 absolute value is less than epsilon. Epsilon is, like I said, again, any number, any positive number. Whenever or when, we're going to write this one 0 less than, in this case, sorry, x minus, what is small a here in this case? Small a is here, this one here. 2 less than delta, any positive number. Okay, so we must show that for any positive number epsilon, we can find another positive number delta, such that x squared minus 4 absolute value of that is less than epsilon when x minus 2 is less than delta and more than 0. So I'm going to choose delta to be a number. I'm going to choose it to be 1, delta to be 1. It's a positive number, okay? But the reason I want to do this is because so that I can write 0 minus x minus 2 to 1. So I can write that. All right. Now you see this. Then what I can do is then x squared minus 4 would be equal to, I'm just going to expand this, x minus 2, x plus 2. Okay. So, all right, I can do this because x minus 2, yep, x plus Okay, so I can actually expand this to this one here, x minus 2 and x minus 2 plus 4. I can do that. I'm just changing this right here to this. Okay, so what I can do right now is I can say x, oops, let me do this, x minus 2. All right, I can put everything in curly bracket here, x minus 2 plus 4 here. All right, so now, because right now I know x minus 2 is less than 1, right? It could be less than 1. So I know that this one right here, this one right here is less than 1. This one right here is also less than 1. All right. So if I know that this is less than 1 and this is less than 1, so I can say that this whole thing right here is less than 1 times 1 plus 4, which is 5 delta. Okay. Oh, I'm sorry. Can say that this is, I can say that this is 5 delta. Because I know this is less than 1, I'm setting delta to be less or equal than 1. And I know from this here, this here, this is less than 1, less than 1. So any result here, whatever x is going to be less than 1 times 1 plus 4, well, less than 5. I think I put 5 delta there. Okay? All right. So, all right. So in this case, then, um, so we have used the results that something like this. This is a triangle inequality. Okay, you don't need to. You can just accept this at this moment. Okay, and then what do? We take. Sorry, let's take this. So we take a delta as 1, or we can take it as epsilon divided by 5, doesn't matter. So whichever is smaller. Smaller. Okay. Then we have x squared minus 4 less than epsilon whenever 0 is less than x minus 2 epsilon value, just now what we had before. And then the required results is proved or proved. Okay. So the question is, what is the limit of this function, okay, when x approaches infinity? Sorry, 0. Okay. So question number 1. The answer is does not exist. Okay. The reason is because, remember, when we approach it from the left-hand side, the right-hand side, plus 1, it is 1. But when we approach it from the approach 0 from the left-hand side, it's going to be minus 1. So in this case, okay, it's Azan right now, so I'm just going to write the answer here. Okay, so now how to find the limit of this? So what's the limit of this function g of x as x approaches, what was it? Infinity. Yep. All right. So one way you can do is this. Okay. Let me rewrite everything here again. One way we can do is we rewrite, I'm going to rewrite everything again just for completeness sake so that it appears correct to you. Okay. One way we can do is what we can do is we divide um, both numerator and denominator by x squared. Okay, basically what we're doing here is up here we divide by x squared and down here divide by x squared. I can do this because this is the same like multiplying by 1, x squared up here, x squared down there. So what I will get from this is, so what I will get is I will divide up here by x squared. What I will get is 3 plus 8 over x minus 4x squared. And down here, what I will get is 2 plus 4 over x minus 5 over x squared. Okay, so now here's a trick that I can do. All right, what I can do is I'm applying the limit to each term. So I'm applying limit to here. I'm applying the limit to this one here, x over x, minus I'm applying limit here also, 4 over x squared. And I'm doing the same down there. So limit of x, I can do this because math is really interesting. Okay, I can do it here. I can do it like that. Now, if I've written it that way, so what I can do? So limit of, okay, let's look at this one here. Let's look at this one here. 3 when the limit x equals to x approaches infinity is still 3. So this is 3. All right. What about this one? 8 over x. What happens if x approaches 8? Sorry, x approaches infinity. So this will become a really big number, and any number divided by a real big number is going to be 0. So this is 0. Okay, the same goes for this one also because x approaches infinity. Down here is going to be infinity times 2. So it's going to be really big number. So this one is 0. So similarly, this one, because there's no x in it, so I can just write 2. Here, same reason, is 0. Same reason, 0. Okay, so what I'm left with is just 3 over 2. We got 3 up here, 2 down here, plus 0, minus 0, everything is 0. So I got 3 over 2. So this is equal to 1.5. Okay. Got it? That's one way. Someone mentions L'Hopital's rule before. So let's solve this using using L'Hopital's rule. Okay, don't worry if you don't understand this method yet, because we're gonna cover it again. But because someone mentioned it just now, so I like to cover it again. So that's the plus 8x minus 4, 2x plus 4x minus 5. Okay, so what's L'Hopital is doing, L'Hopital's idea is you can find the limit here if you can. You can find the limit easier if you can differentiate this with respect to x, with respect to x, and again similarly the numerator, so the denominator you differentiate it with respect to x also. So if you do it first time, then what you're gonna get is limit x. So if you differentiate first time, then you can get x. Sorry, no. So if you differentiate this, 2 brings it here, 6x plus 8. And then if you differentiate this, nope, nothing. Differentiate this, 4x. Differentiate this, 4x, you got 4. Differentiate minus 5, you get 0. So you get this. Okay? Now, all right, we can actually do the differentiation again. Differentiate it again. Both with respect to x. With respect to x. Do it again. Until you get something that you can work with. So here we got 6, differentiate 6x, we get 6, and here 8, nothing, 0. Down here you got 4x, differentiate that, you got 4, 4, nothing. So here it becomes 6 over 4, which is equivalent to 3 over 2. Same thing. This is using L'Hopital's rule. So the answer is 3 over 2. Okay? I show you 2 ways of doing it. So you can correct your answer in the Discord chat box here. So thank you, Simranjin. Thank you, Mubarak. Thank you, Amira. Claire, you got it right.